This is Anthony, and welcome to another session of Matrix Algebra for Statistics and Econometrics. Today we're going to have a look at the concept of span. What does span means in Matrix Algebra? Well, just before we get started understanding a span, let's define a set J, which include four vectors: v1, v2, v3, and v4. All right? They are of equal number of elements. So if v1 has 3 elements, v2 will also have 3 elements, v3 will also have 3 elements, and v4 will also have 3 elements. Or in other words, same number of rows. Okay? Now, we'll just go back to our XP operation that we just looked into in the previous video. Right? Now, our XP operation gives us a vector when we take a real number, multiply it by x vector, and then add it to y vector. Right? That's exact same idea here. But here, there is a lot of different combinations you can have to form a span. Right? So, you can select, for example, create a z1 vector, right? By selecting any real number. Let's say you select 2, and just select v1 from here and v4 from j. So you get a resultant vector of z1. Right? Similarly, you can also get z2 by selecting another real number, 3 v1 plus v3. Right? So in this way, you can have different combination of your a's and x and y, which actually comes from here, and form new vectors. Right? So all these vectors that you can actually get under the universe by selecting different value of the real number a is called the span. Right? So if J is a set, includes some vectors in them, right? So the span of J is all the vectors that can be formed with an XP operation. Right? So you select A's, right? All the A's and vectors. So 2 vectors from the set J. Does that make sense? So all these different Z1, Z2, all the way into Zn, right? All this relates to what we call span, and they are the span for the set J, right? Does that make sense? Right. Okay. Hope that has been helpful. I'll see you later with more videos. Thank you.